Hi, good morning. Thanks everyone so much for coming. My name is Sally Taylor. I'm the Entomology Director for Cotton Incorporated. I've been in this role about a year. I took over for Ryan Kurtz, who's now our Vice President of Agricultural and Environmental Research. And before I was here, I was Extension and Research at Virginia Tech. So I'm going to resist the temptation to look for familiar names in the audience, and I'll try to keep my Southern accent to a minimum, but the more that I see y'all, the worse it's likely to get. So I'm going to talk a little this morning about our insect research program and what our priorities are. And the U.S. cotton belt is big. I don't have to tell y'all, it's the Southern United States. And as you can imagine, the ecosystem, the agri ecosystem, especially in the Southeast, is really different from the Southwest. It's different from California. It's different from Texas, which is a region really unto itself. And all these places differ in the types of bugs they get, so what kind of species invade their fields, and also how many of them. So the intensity of bug pressure varies, and it's heaviest in the Mid-South. I apologize for putting you in red. The colors indicate the number of applications that are required to grow a profitable crop each year. So these are 2022 numbers, and they represent the most recent insect figures that I have. And, other regions, were the yellow, one spray application a year. And then California and the Southeast, where I'm from, is kind of intermediate with 2 to 3. Almost all the cotton we plant is Bt cotton, and that means it's been transformed with a gene for insect control, typically caterpillars. So we're seeing more cotton planted that controls thrips additionally. Most of our cotton has a seed treatment, again for thrips, and about 14% gets an in-furrow treatment. Losses and cost, so this again, 2022 numbers, it's $166 an acre. And that's significant. That's no small amount of money. I don't have to tell y'all that. And I want you to know that we focus on helping you spend less money and knowing when it's profitable to put those inputs in the field, that it really is necessary to control insect pests. So no matter where you live, there is a bug or two, sometimes even three, that can do this to your field. And this is an example. This picture was taken by Dominic Reisig and Alejandro Del Pozo at North Carolina State University. And this is just an example from recent years of what happens when you plant Bt crop on the left-hand side of your screen where you see cotton, and non-Bt beside it on the right. So this is all bollworm damage. And some of you may remember it and some of it you may not. So for reference, these traits were commercialized in 1996. I was turning 16 that year, so I was not paying attention to what my mom and dad were planting in the field and what kind of technology it had. And I'm in my mid 40s. So as our population ages, as your children and grandchildren take over farms, they may or may not have seen things like a bad bollworm infestation. They've never seen a pink bollworm. They've never seen a boll weevil. And for that, we're grateful, but we don't want to forget that we control insects for a reason. Overall, we have done a fantastic job in the US reducing insecticide applications, and that's thanks in part to boll weevil eradication and the introduction of Bt crops. So this slide just shows the number of applications on the vertical axis. So the taller the bar, the more applications you have. Shifting by year to the right, to modern day, as we're down to 1 to 2 applications from a height of 5 to 6 in the late 80s, early 90s. So we've just done a great job, and our farmers are so knowledgeable and just so good at making these decisions, because in large part you have to be. If you're not a smart farmer, you're not in the business. What are we dealing with today in this post-eradication, post-Bt world? We have around 23 arthropods, or most of them are insects that can cause annual losses. So they're problems every year, or they can be. And there are 7 big heavy hitters that are responsible for most of our economic damage. And those are lice or plant bugs, cotton flea hoppers, stink bug, bollworm, thrips, spider mites, aphids. And I highlighted certain ones on the list, and there's some entomologists in here that are like, oh yeah, I see why you did that. And if you don't see why I did that, let me tell you. It's these are piercing, sucking pests. They have stylets that they insert into plants to suck out sap or sugars, whatever they're looking for in that plant. And by and large, they represent some of the biggest problems in cropping systems worldwide today. And this is true for cotton as well. And part of that reason is climate variability. So these are a suite of insects that are able to take advantage of warming temperatures. And in this graph, this is data from the Tidewater Research Station in Suffolk, Virginia, where I worked at Virginia Tech. There's a little arrow here on the right-hand side that lets you know where that is in the United States. And this is our cotton growing degree days from 1995 to 2018. And I apologize that I haven't updated this. I've got small kids. And what you see with the slope of the line in this equation here is every year in Virginia, we gain about a day of heat for cotton plant. And that explains half of the variability of the temperature annually. So for every year in the past 20 years, we've gained a day of our season, which I think is great. Like Virginia grows some awesome looking cotton. And when we have time to make the crop, we can have better variety selection. We just have time. And though that's good, it's also in some cases bad because insects can take advantage of this temperature too. So the warmer it is, the faster an insect develops, the quicker those generations turn. And oftentimes the size expands as the generation turns, right? Because they don't survive the winter that well. That's like their time of hardship. So this looks like the same graph because, you know, just different units. And the units in this case are Lygus linealaris or plant bug development units, so degree days. So just like cotton, the hotter it is every year, the more plant bugs we have and the faster generation turns. So at our current temperature, we see a new generation of plant bugs about every 3 weeks. And that can be problematic where they occur. The other thing that's going on that can make it difficult to anticipate what bugs you're going to get or how you manage them are things like precipitation and the variability between seasons and within seasons that we currently have. This is a graphic from the USDA Southeast Climate Hub. And it's just, if you have time, like everything's fixed in the shop, you've got nothing to scout, it's raining, play with this website because they've got great resources about how to be resilient in the face of climate variability. And from an insect perspective, you're going to face different things in a drought than you are in a really wet year. And the examples, I apologize, I only wanted to use my pictures or my articles. I have here is spider mites versus slugs. So a dry year is going to treat you differently than a wet one. And within the season itself, so where we are in the Southeast here in Virginia, we'll hit drought for just a month of the year. So we may have average rainfall that's the same for the season, but we've had that rainfall in fewer and fewer events that are punctuated by drought. So a really heavy rain, drought, really heavy rain. And our researchers have done a fantastic job of looking at how that changes your pest pressure. Moving on. The other thing that true bugs take advantage of really well is interplant movements. So they're polyphagous. They eat a lot of things and they eat a lot of crops, unfortunately. So if you're a row crop producer, you're going to have stink bugs, or you may have stink bugs in your corn. You may have them in your cotton. You may have them in your soybean. Boom, they overwinter. They're in the field. I mean, what's it doing? It's not eating these beans, right? But it can overwinter there. If there's residue, it may survive a little bit better because the temperature. I'm not encouraging you to not plant cover or to till, just to think about how these things are affected by our systems. So this bug can move from crop to crop to crop. wait over the winter, start again in the spring. And that's why they tend to be more problematic for us as crop producers. One of the things that Cotton Incorporated has sponsored and we continue to sponsor are climate and landscape models. So these are models that take in, let's say for example, a focal field of cotton and considers what's within 3 kilometers, what's within 5, what's within bigger, what's the temperature, what's the rainfall, what was last year's crop, what's the surrounding crop, what's the tree stand age, what's the minimum temperature. And you can input all of these things into rather sophisticated statistical software, and it can input uh, you input things and it outputs things like your risk level. It can tell you what that field is more likely to get in terms of insects. And this is useful to a producer, at least I think it is, because you know where you can allocate those resources. Like if I know a field is going to be a problem, I can spend more money there, or I can anticipate spending more money there, but I'll spend more time there scouting. I'll give it a little bit more attention. I'll think more about logistics when I'm spraying, knowing that this area is higher risk than another area. And this is especially important in the Southeast because we may farm, it's 500 to 1,000 acres, but this is over several counties. So average field size can be 20 to 40 acres and they're spread out. So you have to think about where do I need my resources and how am I going to move them around? And that's one of the things we're trying to help you with. So this slide gives an example for Lygus in the Southeast and fields where there were wheat and soybean grown nearby. So double crop soybean, you may call them wheat beans. Additionally, had higher plant bug populations. If you had clear cutting or forest disturbance, so if you had logging, you had higher plant bug populations. If it's warmer in the winter, if the lows are cooler in the summer, and typically that happens when you're around large bodies of water, like the eastern part of the state, you have more plant bugs. And if you have more land in agriculture. So it can vary quite a bit around the region. And we've done this for a number of insects. And the other unfortunate aspect with some true bugs, especially in the case of plant bugs, is insecticide resistance issues. So we may have only been spraying for them since BT cotton knocked bollworm out of the system. And then we're like, wait, what's this? Right? Because they weren't a problem when we were treating other insects because they were there being treated. So by the time they were our focus, they had some resistance issues especially to the older chemistries. So this slide just gives an example of some of the work that we've done monitoring resistance in populations. So where is it? How is it evolving? This slide in particular shows plant bug and pyrethroid resistance in the Southeast over the season, left to right. So you've non-cotton host on the left. That blue color indicates, hey, your pyrethroids are probably working pretty good if you were spraying or cover crop, which you're not. And then by the time early season and late season, they're losing efficacy as those populations evolve resistance through successive generations. This is just, we know you have to spray for bugs, and I want you to do it most effectively. And that means the fewest times, right? So resistance monitoring is something that we invest some of your money in. Now, the insect on this list that is not a true bug, bollworm. And it's not something that a lot of people are used to scouting for. It's a harder insect to scout for. We recommend in most areas where this insect is a problem an egg threshold. If you've never seen an egg, it's not easy to find. Once you're trained to find it, you're pretty darn good at it. The brain is an amazing thing. And then we plant almost 100% BT cotton. Still about 13% of our acres are treated yearly for bollworm infestations. And the reason for that is BT resistance. The same genes that are in your cotton to control bollworm are in your corn. And now these genes were designed for European corn borer. and they're really effective against European corn borer from introduction till today. If you're not on the East Coast, you've got other borer species, Southwest corn borer, for example, and they also, to some extent, control bollworm or corn earworm, though they weren't designed for this animal and they're not high dose for this animal. So this animal spends a generation of its life, the second generation of its life, in corn. That's the crop it's looking for. And when it eats those BT traits, or when it survives those BT traits in corn, we can anticipate a problem in our cotton. And that's kind of where we are now. So we've lost efficacy of some of our cry proteins. Our 3-gene cotton is still working extremely well, and it's in all of our benefit for that durability to remain. And that's part of what my program does, is invest money in alternative strategies and also in monitoring where this resistance may be. So if you are in a high risk area, you can anticipate scouting and potentially spraying for this pest. The other thing that's going on with bollworm, which is more of a concern in the northern US, so where cotton is not necessarily grown, but there's always a but when it comes to the world of entomology. Bollworm, as successive generations pass, they migrate northward. We have evidence from some of our projects that there's a return journey in the fall. So some of the ones that we find in the spring, or that we capture late year or early the next year, will actually be from a different latitude. So they'll travel back. So as they eat BT crops, as they move up, oh great, now they're back in the south to start this journey again. And what's happening with climate variability is the soil temperatures are allowing them to overwinter. So they drop out of the plant and they burrow into the soil. They overwinter farther and farther north. And we can anticipate that this zone will continue to shift in future years. This is from a paper from North Carolina State University, predicting where bollworm can survive in the US. And this is another one of my students' papers with Roger Schurch at Virginia Tech, looking at fire ant spread in Virginia. And if you look at this D through E state map, that shows where the habitat is suitable for fire ants as we move through time. So by the time you get to 2070, the entire state of Virginia can sustain this insect, which is not a problem for cotton. They're actually pretty good for cotton because they're effective caterpillar predators. It's just an example of things are different for us now. No one has to tell you this if you've lived in the same place for 40 years or 60 years or even 80 years. You've seen it change. But it lets people know how they can anticipate it continuing to change for their children and grandchildren. The other thing that's changing, and partially this is climate variability, and partially it's global trade. So bugs are coming to us hidden in wood pallets. They're coming in shipments on boats, like planes, trains, and automobiles. I've got a great picture, it's not in this presentation, of kudzu bugs on the back of an 18-wheeler. Like, they're adept at getting across man-made borders, right? Like a state border is nothing to an invasive species. And one of the things my program does, and I invest your money in, is monitoring these bugs that are invasive, and also anticipating what kind of control tactics we can use, what kind of spread they'll have once they're in the United States, what kind of impact they'll have on the crop, what we may already have that we're using in the crop that can additionally control it. And this varies quite a bit by region. Like if you look out at California, they're dealing now with the cotton seed bug. And I want to say it's not in cotton. It's in surrounding landscape. So it can survive off hibiscus and other related plants. And it's something to keep an eye on, watch. What does it do? It eats cottonseed. It could be a late season pest. Cotton boll weevil is still alive and well. Places where cotton grows native year round are not going to be able to eradicate it. So there's this constant threat of reinvasion from Mexico. And that's something that South Texas producers have done a fantastic job watching and monitoring. And some of these places aren't safe. And these women and men are just so brave and doing our entire cotton belt a service by being the front line on this insect. So I'm grateful for the program that eradicated it, but I want to not be scared, but be prepared should we ever face it again. The other issue from the South, old world bollworm. So this is related to corn earworm, and it can breed with corn earworm. And we're finding out that it already has, and we're dealing with a hybrid issue in many parts of the United States. And it just has a different suite of insecticide resistance. So those genes that allow it to survive a pesticide spray are being taken in by our bollworm that can survive a BT crop. Great, now we have a superworm. But please don't quote me on the superworm thing. That's kind of a worst case scenario. But part of our job is thinking about those worst case scenarios so you don't have to face them. Like if you're like, well, I've never seen a cottonseed bug. I'm like, oh, that's because we're winning, right? Like we want to continue winning. We want to continue not seeing these things. Cotton jassid is a pest in Puerto Rico where a lot of seed farms are. Hibiscus mealybug is something that Florida is dealing with, though it's not yet in cotton. And then we have a little population of old world bollworm that's established by the Chicago airport. So it can be invasions from the north. And what's happening is we call it like a Goldilocks zone. It's not too cold, it's not too hot, it's just right. And like for example, the Central American locust, its Goldilocks zone used to be, northern Mexico to about the Yucatan Peninsula. And as the climate has changed, it's shifted to South Texas. Now it's not in South Texas, but it's something we need to keep an eye on because all things considered, that's a really great place for it to live. So our mission, the overall mission of our division in Cotton Incorporated is to increase demand and profitability of cotton through research and promotion. And the overall objective of insect pest management is to develop those strategies that are cost effective and environmentally acceptable. And to me, cost effective and environmentally acceptable can be expanded to being like logistically acceptable. What do you have time to do? And part of that is growing up in a farm family. I understand that you can't be everywhere at once, and you can't do everything right all the time. And a lot of times you're just doing the best you can. So I'm not investing your money in a lot of things that are going to add complexity to your farm because realistically you can't do it. So sometimes it's a compromise between this is the 100% the way that you do it to control the bug, and this is a way that takes about half the amount of time and is like 95% right. And that's the kind of stuff that I think is valuable investing in. For entomology, we have 43 projects in 14 states. So there are quite a bit of projects. There are probably several, if not more, that are local to you. We have 3 working groups, the Mid-South, Southwest, and the Southeast, working on problems unique to the regions. I focus money on graduate and undergraduate training, which is really important. If you've been ever on a hiring committee for maybe your local university or extension service, it can be hard to find trained and qualified people that want to live in rural places. And as someone who loves and is from a rural place, it's really important to me to get these young women and men trained and out into the workforce. So that's a good use of our money. And our program overall has an IPM focus, and I won't spend a lot of time talking about IPM, but I do want you to understand that when we talk about integrated pest management or IPM, we're not talking about the lack of insecticides. What we're talking about is integrating all different kinds of strategies to control into like an overall management plan. And most of what you're going to be doing with IPM is prevention. Most of it's going to be cultural, sanitation, removing the stalks at the end of the season is an example of that. Physical, mechanical control, biocontrol, and a lot of times that's conservation, so not using those insecticides before you have to. And then the very top of the pyramid is your chemistries, is like kind of like your remedial things, the last thing you reach for in your toolkit. And circling back around to the first pest we talk about, so we're investing in an integrated strategy for Lygus, and that includes, from a genetic standpoint, we're looking for resistance in our current cultivars, what makes a plant less habitable, like what makes it like a poorer host, right, for Lygus, because there's variability in our varieties. So why not measure what's out there now? But we can also identify resistant genes in plants that can be inserted in plants to make that next generation of transgenic crops. And we can identify pest genes for developing therapeutic targets that are more specific to that pest insect. We don't ignore chemical control. We refine thresholds. So when is it absolutely critical to spray? How can we sample quickly and make the right decision? Let's watch resistance. Let's spray once and let's spray the right thing. And let's also look at how those plants compensate, so you know what your actual losses are. So far as cultural control, we do landscape movement, climate models, how they use different hosts, and biological control, looking at natural enemies and how different chemistries labeled for Lygus may affect those guilds. Similarly for bollworm, cotton genome editing for the same kind of things. Can we add genes? Can we take away genes? Can we target pest genes? What kind of sprays are going to be effective? Should our BTs stop working? Where are BTs at high risk of start working? And how are these populations evolving and how quickly? We can also adjust our thresholds by infestation timing. So as the climate shifts their habitable zones, we may see them in different bloom times of the year in cotton. There are also some promising biologicals we're investing in, like entomopathogenic nematodes. So not all nematodes are bad. Endophytic management and pathogens, things like viruses. Thrips control is going to be so important. And I wanted to talk a little bit about thrips and orthine. We may have less products in our toolkit, and I want to assure you that we don't ever want that, but it's going to be okay, because we've developed other products like Thrive On. There are also some sources of natural resistance in some cultivars. There are different insecticides with varying degrees of efficacy and selectability and residual that we can use. We can also adjust those management inputs by risk within a region, which is a tool that North Carolina State developed, and also look at selecting for pests and not their natural enemies. So I encourage you to talk to your local extension specialist about thrips control if this is something that concerns you, and maybe we can go into more detail about it as the situation with orthine evolves. It's great to do all the research. The research has to be in your hands. You have to be able to use it. So our Cotton Incorporated invests in outreach and extension education. This is an example of a beat sheet that my program at Virginia Tech made with the help of Cotton Incorporated and distributed free of charge to our producers. I could probably get you one. If you need one, let me know. We also put educational cards with them so people would know what they're looking for. We went out into the field and trained people how to use them. We didn't just hand them a tool and say, here you go. We're like, this is what you do. This is how easy it is. And this is how quick you can do it. There are virtual things, apps, websites, just everything on the web. Cotton and coffee, right? There are just a lot of resources out there that we spend time on. And what we're trying to do is reduce those insecticide applications, use your resources better, have information at your fingertips, and additionally help those researchers that we fund identify new awards, get more funding sources, and turn that research into big dollar impacts. And then ultimately, part of that's going to be training an agricultural workforce to face the future challenges. I was going to talk about deer a little bit, but I think I'm out of time. I just want you to know that we're not ignoring deer, and I'm your deer person. So if you want to call and complain about deer, please do, because like I care, I do. And some of you hopefully are like, what is she even talking about? Like a deer in the insect presentation? but they are animals. So these are photos from UGA just showing that they graze on cotton now. And this is an evolving problem in the Southeast, and it's something that we're currently working on. And we know it causes yield loss, and we know it causes maturity delays. This is from some research of Guy Collins at North Carolina State. And we're working with these researchers on helping you with this problem. Again, it's going to take an integrated approach for deer, just like it does insects. And that's going to be everything from breeding and I put screening existing cultivars, evaluating repellents, which I'm going to tell you largely aren't working. But we want to make sure if you're spending money on them that we know when they can work, if they do work, and how you apply them to make them work. Also, like intercropping, how are they moving the landscapes? Can we develop population models to know, like, if you're going to invest money on building a fence, where you should do it? So barriers, sound makers, scarecrows, you have ideas, I'm ready to hear them. And I think with that is my end. This is my email. Feel free to shoot me your ideas. If you want to call me, don't call my office. I don't know how the phone works. This is my cell phone. I encourage you to call over text. I'm kind of a boomer that way, but I will respond to text. It just generally takes me longer. And we're here for you. Thank you so much for your time this morning.